Hello everyone, my name's Aaron Miller, and I'm here today to answer one of our frequently asked questions. And that is, what steps do I have to take so I can run my deep learning models on AWS Tranium and Inferentia? To make this easy, AWS has partnered with Hugging Face, where many data scientists and machine learning engineers are already running models based on their popular Transformers library. Customers running models from Hugging Face can use the Optimum Neuron library as a drop-in replacement for the Transformers library they're already using. I've got the Optimum Neuron documentation page loaded in my browser tab here. Customers can get started quickly with one of the tutorials or how-to guides. And if you scroll down, you'll find the link to supported architectures. I'll click on that. Optimum Neuron supports many of the popular large language models, including Llama and Mistral. Highlighted those here. And if I scroll down further, you'll see support for diffuser-based models as well, including Stable Diffusion. So what does this mean? Customers using any of these Hugging Face models in the supported architecture list can get up and running on AWS Inferentia and Tranium quickly, and by only updating a few lines of Python code. And in this short demo, I'll do just that, showing you the steps to move a Stable Diffusion model running on a GPU to running on AWS Inferentia 2. What I'm showing here is a Jupyter notebook running on Inferentia 2. If you aren't familiar with Jupyter notebooks, this is just an interactive Python environment running in a web browser. The Python code here is an example of using the Hugging Face library to load and run a Stable Diffusion model on a GPU. In our example, we'll only need to change 2 lines of code to run on Inferentia 2. I'm going to swap out the Stable Diffusion pipeline from the diffusers library to the Neuron Stable Diffusion pipeline from the Optimum Neuron library. First, I'll update the import line to import the Neuron Stable Diffusion pipeline. Then I'll update where the model's loaded to use the Neuron version of the Stable Diffusion pipeline. You'll note there are a few extra parameters passed to this function, and I'll highlight them here. This is because these additional parameters are required as the model is compiled to run on Inferentia 2. Let's take a moment to talk about this compile step, why it's important and why it's required. We compile models on Tranium and Inferentia to take full advantage of these purpose-built accelerators for deep learning. Compiling a model is a one-time step, and these additional settings like export, batch size, image height and width are included as part of the optimization. I mentioned compiling's a one-time step. You can save the compiled model on disk or push it to the Hugging Face hub like I did, so you can quickly load the model. Here you can see I've pushed the model to the Hugging Face hub, and that means I can run it anytime I want without having to compile it again. Now that I've made those 2 changes, let's run the model. I've got a fun prompt here for Stable Diffusion to create an image of a cat riding a bike. I'll run the model, and it's running now on Inferentia 2. And there you can see the cat image. I'll run it one more time just to see another picture. So to wrap up, I've shown how easy it is to run your deep learning models on Inferentia and Tranium using the Optimum Neuron library. Customers using supported Hugging Face models can move to Tranium and Inferentia by updating just a few lines of code. There's a one-time compile step, and then your models will take full advantage of these purpose-built accelerators. Thanks for watching.